Okay, an example of two-dimensional momentum. Oops, 2D momentum, so you can do your homework questions. So we have ball 1, mass 4 kilograms, initially going 10 meters per second. Smucks into ball 2, mass 5 kilograms, initially at rest. After the collision, ball 1 goes off with a velocity of, let's say, 6 meters per second. So this is V1 final. And at an angle of, let's say, 36.87 degrees. And that would be clockwise from the original direction. And ball 2 goes off this way, and the question is, what is V2F? So V1F has an X component and a Y component, which we can find because we have the hypotenuse and we have the angle. And so using our conservation of momentum, we can solve for V2Fy and V2Fx. Okay, so we're going to use our momentum equation first in the x direction, so m1v1 initial x plus m2v2 initial x will equal m1v1 final x plus m2v2 final x. So in the x direction, this guy's only moving in the x direction. So the v1 initial x is really just 10 meters per second. M2 is not moving at all initially. And we're trying to find V2Fx. So take this term to the other side. So it'll be M1 V1 initial. I can drop the x because it's only in the x. Minus M1 V1 final. And the x component of V1 final is cosine. So this will be cos theta 1 will equal M2 V2 Fx divided by M2. Okay, and so we can fill our numbers in to get V2Fx. So V2Fx will equal M1 was 4 kilograms, V1x initial 10 meters per second, minus 4 kilograms, final was 6 meters per second, and then cos of 36.87, and then we're going to divide that by 5 kilograms, and we'll get V2Fx. So what is that? 40 kilogram meters per second minus 24 times 0.8. So 19.2 kilogram meters per second over 5 kilogram meter. Oops, sorry, just kilograms. So divide by 5. So in the x direction, 4.16 meters per second. So then we're going to do it in the y. So M1 V1 initial y plus M2 V2 initial y will equal M1 V1 final y plus M2 V2 final y. Now if you look at the diagram in the y direction, initially M2 is still not moving, but M1's not doing anything in the y, so it goes to 0. So we have 0 equals M1 V1 final. The y is the sine, theta 1, plus M2 V2 final y, which we're trying to look for. So take the one term over, and so it'll become negative, and divide by M2. So negative 4 kilograms, V1 final was 6 meters per second. Sine of 36.87 divided by 5 kilograms. So 4 times 6, 24. 24 times 0.6 is 14.4 divided by 5. You get a V2Fy of 2.88 meters per second. And it works out to be negative, which simply means opposite V1, y. Okay, so once you have your two components, then you draw them. So this is 4.16 meters per second. 1 was going down, so for 2, the negative actually means going up. 2.88 meters per second. And then you're going to square them, add them together, Find the square root, so 4.16 squared. Take the square root, so it'll be 5.0596 meters per second. Find the angle. And you get 34.6, so V2I 5.0596 meters per second. This angle is 34.695. So at an angle of 34.695 degrees, and it's CCW, a ridge. Okay, so that's how you do your homework. Okay, sum in the x, sum in the y. Once you have your two components, create the right triangle and do the Pythagorean theorem and the tan to get the angle. Okay, so 509, the three questions that are there. I think there's 35, 36, and 37. All right, very good. See you tomorrow.